Hello, in this video tutorial I like to show you how you calculate the heat capacity for the building. We have the heat capacity in this cell here on the front page in the BE15. When you have to calculate the heat capacity, you have to know what kind of constructions you have in the building. So you know what is the wall made of, and what is the roof and ceiling made of, what is the floor made of, and the partitions walls. That is important that you know the material for these constructions when you have to look into the heat capacity. We have a schedule to calculate or to find out what is the heat capacity for the different material. This schedule is a translation from the SPI 213. Here you can see we have the ceiling, the floor, the external wall and the partition walls, and then also we have fixtures for all the furniture and stuff that we have inside the building. If we, for example, have a dwelling that I have over here, where I have a ceiling, a suspended ceiling, and I have a concrete floor, and I have a wall made out of an external wall made out of irrigated concrete, and I have walls made out of timber with gypsum. Then we can see that the ceiling has a heat capacity of 3, and we can see that the floor has a heat capacity of 60, and because it is a dwelling, we know the compactness of the building is small, so we can see here that the heat capacity is 10, and the partition walls we have was made out of timber with gypsum, so we can see that has a heat capacity of 13. And then we have the fixtures. So we add all these together, and then we have the heat capacity. So this is the way that you calculate the heat capacity. To find out which compactness the building has, you need to find the external wall area and divide it by the heated floor area. And if you have 0.65, then it's small. If it's 0.45, it's medium, and if it's 0.25, it is large. That means that you take the external wall area and divide it by the heated floor area. If you have to find the room size, if it's small, medium or large, you take the partition wall area and divide it by the heated floor area. Typically, we can say that a dwelling is small, and big rooms, office rooms and classrooms are large, and then we have something in between there as well. If you have a building where you have different constructions, so in one part of the building you mainly use concrete, and another part of the building you mainly use timber for the constructions, then you divide the building into 2 buildings to find the heat capacity for each building, and then afterwards you find an average for these 2 buildings for the whole building. So if we, for example, have a building primarily made out of concrete, we find the heat capacity for that. And we have another building where we mainly have the constructions made out of timber. We calculate the heat capacity for that building. And then we take an average, which I've shown down here in this formula, of these two heat capacities. So that means that we need to have the area for each building, and that would be the heated floor area that we use for the building. So this is the way that you can find or calculate the heat capacity when you have buildings made out of two different kind of constructions. This is all for now. I have made a small assignment that you can look into to calculate heat capacities for different buildings. Thank you for now.